The final section in Chapter 7 deals with project crashing. It's not uncommon for a project manager to be faced with a project that's either behind schedule or the customer has moved the required completion date forward. In such cases, the project needs to be crashed. You pay to have activities accomplished at a faster pace. Let's assume that the GeneralFoundry project has a new completion date. It needs to be finished now in 13 weeks. So we're going to crash the project to get it done, crash it to 13 weeks. We're provided with the information that we need to do that. Programming the model isn't very difficult, but setting up the constraints can be a little bit of a challenge. So I have developed a worksheet that if you will input the information in the worksheet, it will give you what you need to reliably set up the crashing model. Here are the headings that I use to lay out the worksheet. You may want to pause the video and copy those headings. And we've been provided with the activity. We've used that in previous examples. We've calculated the normal time for the activity. We know the normal costs of each activity. We've derived those values from the earlier exercises. So if we place those there, be careful to place them there accurately. You may want to again take a moment and pause the video, copy these values. In addition to these values, we've been provided in the text with the crashed times. This means that activity A can be completed now in 1 week rather than in 2 weeks with additional resources. The same with activity B. Instead of taking 3 weeks with additional resources, it can now be completed in 1 week. Then we're provided with the crash costs, so the new costs for each activity. You want to take a moment and copy those. We need to calculate the crash limit constraint. It's a constraint that we'll use in our model. I'll show you where to place that in a few moments. I provided you with the equation for each of these calculations here. So the crash limit constraint equals the normal time minus the crash time. So the number of weeks that the activity can be shortened. Copy that down. Then we need the periodic crash cost, the amount of money that each period will now be increased by as a result of project crashing. Provided you with the equation that is the crash cost minus the normal cost over the crash limit constraint. Now we're going to take a moment and enter in the precedence relationships. The precedence relationships simply create a separate line for each of the precedent to following activity relationships that exist in the model. So for example, A precedes C. A precedes D as well. We need to represent that here, so we'll represent it this way. A precedes C, and This is just my choice for using the two dashes and the greater than sign. There's nothing magical about this. It's just a way of indicating that. A precedes D. Now if we look down, we can see the rest of the relationships. B precedes D, C precedes E and F, D precedes G, E precedes only G, F precedes H, and G precedes H. So we're going to indicate that here. B precedes D, and so on. All right, once you have these, you can enter in the precedence constraints. The precedence constraints are the time constraints for the preceding activity. So in this precedence relationship, the precedence constraint is the normal time for the preceding activity. A is the preceding activity here. So the normal time for A is 2 weeks. The precedence constraint then is 2. Again, A, the normal time for A is 2 weeks. The preceding activity here is B. The normal time for B is 3. The preceding activity in this relationship is C. The normal time for C is 2. Again, C. The preceding activity here is D. The normal time for D is 4. The preceding activity here is E. The normal time for E is 4. The preceding activity here is F. The normal time for F is 3. And the preceding activity for this relationship is G. The normal time for G is 5 weeks. Now we have all of the constraints that we need to complete our crashing model. So let's go ahead and create that. These are the headings that I use for the crashing model. I've included these because they're in the textbook. They relate back to the equations, and we'll talk about the equations in class. You don't really need to include these, just as long as you have a start time for each activity and then the crash time for each activity. We'll set up our solution value here, which yellow to make that, and then we'll assign our crash costs. We'll place them in and our constraints. On the previous worksheet, here is the periodic crash cost data. So we'll copy these and we'll just paste these here. Now we're going to paste them a little differently. First of all, we don't want to paste the formulas. Remember, that's a formula on the other worksheet. And we don't want them vertically, we want them horizontally. So I'll right-click here and select Paste Special. And I'm going to indicate that I want to paste the values only, and that I want to transpose those. When I do that, it will take only the values and transpose them here. That way I don't have any mistakes typing the data in. Okay, the next thing we need are our precedence relationships. The first series of constraints, we have those. We've laid them out here. So if we just take these and copy them and place them in the constraints portion, these are all greater than or equal to constraints, so we can assign over here in column S a greater than or equal to value. We have to leave column R to be the cell value of the calculation. We'll copy these down to 16, row 16. These are all greater than or equal to values. And here is where the constraint, I'll label that, will go. We calculated those constraints. They're right here. So we'll copy these. So that takes care of our constraints. Now we need to put in our crash limit, and the only way to do this is to type. You could abbreviate it with CL, whatever. I'm going to type crash limit A, crash limit B, all the way down to crash limit H. Once I have that, then I will put in the crash limit constraints. Go back to here. We have the crash limit constraints. Here they are. I'll get those, copy them, place them here. Again, careful to paste the values. We don't want the formulas. And these are all greater than or equal to constraints. That's the minimum time these things can be accomplished. Now the final constraint is the project completion constraint. That is a less than or equal to constraint. And it needs to be less than or equal to 11 weeks. The reason why, the new project completion time is 13 weeks. So the project has to be completed in 13 weeks. We know that activity H is the last node of the project. It takes 2 weeks to complete standard time. So we take 2 from 13 and we get 11. So the new completion time, 13 weeks, less the standard time for the last project, 2 weeks, gives us the project completion time of 11 weeks. Now we're ready to lay out the model. I'll draw some boxes here. Now we're ready to lay out our constraint details. The first quadrant, we're going to lay out the precedence relationship constraints regarding the start time. So we're in this quadrant. The rule here is that the preceding activity takes a -1 and the following activity takes a +1. So the preceding activity in this relationship is A. Here's the column for A. A gets a -1. The following activity is C. Here's the column for C. C gets a +1. The preceding activity is A, -1. The following activity is D, a +1. The preceding activity is B, a -1. The following activity is D, a +1. Next, we enter the crashing constraints. And in this section, it's the preceding activity that gets the value. So the preceding activity here is A, so it takes a 1. The preceding activity here is A, it takes a 1. B, turn that on with a 1. C, C. Now the crash limit constraints, simply turn those on for each variable. Turn that on for each constraint. Then project completion, we indicate the start time for activity H and a -1. I will explain these numbers in class. These numbers derive from the formulas used to do this manually. I'll show you the equations. Now we're ready to enter our sum product statements. And just like with the other sum product statements, we're going to take sum product and the solution set. Make that absolute. And the row to our left. Then again, sum product. The solution set. Absolute, comma. The row to our left. That is the case all the way down, so I'll just copy that to the end. Click on the Data tab, select Solver. See that the objective is R6, which is the green cell. Crashing is a minimization, cost minimization problem, minimizing crashing costs by changing the cells in the solution set subject to the following constraints. So let's add a few constraints. Cell values for our greater than or equal to constraints are here. They are greater than or equal to. The constraints themselves are here. We'll add another set of constraints. The cell values for our less than or equal to constraints are here. They are less than or equal to. The constraints themselves are here. No more constraints to add. Say OK. Simplex LP model and solve. I'll say OK. Solution 2250, the cost of crashing the project from 15 to 13 weeks.